Here is a question. The manufacturer of aspirin claims that the proportion of headache sufferers who get relief with just 2 aspirins is 53%. What is the probability that in a random sample of 400 headache sufferers, less than 50% obtain relief? If 50% of the sample actually obtain relief, what does this suggest about the manufacturer's claim? And then in part B, it is asking repeat part A using a sample of 1000. So how does the result change if our sample size is 1000 instead of only 400? I highly recommend to start each question by making a drawing that shows the situation and the problem that we are looking to solve. What is the guy claiming? The guy claims that 53% get rid of their headache after 2 aspirins. Now we take a sample of 400, and the question is, what are the chances that from a sample size of 400, 50% or less essentially get the headache? So it's 50% of the sample actually obtain relief. What does this suggest about the manufacturer's claim? Yeah, which means I have to calculate what are the chances of taking a sample of 400 and my result is as extreme as 50% or even more extreme. Even more extreme means even further away from the population mean. So in this case, it's 50% or less, right? If the population mean would have been to the left of 50%, it would have meant 50% or more. In this case, 50% or less. How do we proceed here? We should calculate how many standard deviations are we away from the mean, and then we just look up in the table essentially how likely or unlikely is this to be this many standard deviations away or even further than. So essentially what we are doing here, we are looking for the probability that my sample mean, which is p hat, is smaller than 50%, which is, now I have to simply insert that formula. So the probability that the sample size minus the assumed population mean, because what we are doing here is obviously hypothesis testing. I'm sure you guys recognize it by now. And then I divide it by the standard deviations, 1 minus p over n. That whole thing is smaller than 0.50 minus 0.53 divided by, and of course I take here the population mean. I take the assumption that I'm testing here, right? The assumption of the hypothesis that I'm testing, which is 53%, multiplied with 1 minus 53%, and that whole thing divided by 400. And of course, the square root goes over the whole thing, so it has to go down. It's numerator and denominator. Okay, it's just plugging in the values and calculating. So what I have is here minus 0.03 on the top. So this on the denominator, I think is 0.02495, and this is minus 1.20 standard deviations. Next step is what? Is just looking it up in the table. We use for this. Which table do we use? Z-score or T-score?
Z-score.
Exactly, because it's a binomial case, right? Either your headache is gone or not gone. So Z-score minus 1.2 standard deviations. And then again, of course, we have to pay attention to see that we're looking for the same thing that's shown in the table, right? In the table, we look here, we see it's the left tail that is showing us. The value in the table is the left tail. And are we looking for the left tail or the right tail? As you can see in the graph that I drew here, it is the left tail as well, right? The green area that I marked is the left tail. So minus 1.2 standard deviations, it's 11.51. Actually, I should have written it a little bit nicer. Let me do that. Okay. What is it? The probability that Z is smaller than minus 1.2 2 standard deviations, and that is 0.1151. So we have, I think we called it weak evidence or something like that. His claim may be true, right? Now in part B, it's asking, what if we get a sample size of 1,000 and we get the same result? So in sample size of 1,000, getting 50% or less. What do you think, how the result will change? Well, sample size of 1,000 means that the distribution is more centered around the mean, right? Which means that this probability decreases. So instead of 11%, we would get a much smaller number. You would have to plug in the values, the same values, just instead of here having, so for part B, everything the same. It would just be parentheses, blah, 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 smaller than, again, 0.50 minus 0.53 divided by 0.53 multiplied with 1 minus 0.53 divided by 1,000 instead of 400, right? Everything else remains the same. So, but our result would change to P, the z-score would be now 1.90 standard deviations away. And 1.90 standard deviations, if you look it up here, it would be 2.87%. 0.0287. So it becomes extremely unlikely. So what he says would be probably wrong if our sample size increases to 1,000. Is that clear for everyone?
Yes.
Yeah, okay, wonderful.